All right, today, ladies and gentlemen, we are going to be talking about Unit 5, Notes 2, Graphing Quadratics in Standard Form. And so we kind of started working into this today, so now we're going to take what we used in the last notes and put it into what we're doing today. So first, let's talk about different parts of the parabola. I've been throwing words out like axis of symmetry, vertex, and things like that, and now we're going to actually kind of see what they mean. So here are the different parts of the parabola. First, the axis of symmetry is what divides the parabola into two identical halves. The vertex is the highest or lowest point on that parabola. If a is greater than 0, remember a is that coefficient with the squared term. If a is greater than 0, then the parabola opens up. And we refer to the vertex as a minimum. That makes sense because it's the bottommost part of the parabola. So it would be the minimum point. If a is less than 0, which means it's negative, so if we have a negative coefficient on our square term, then the parabola is going to open down. And then the vertex is referred to as a maximum. This makes sense because it is the topmost part of the parabola, making it the maximum. So let's take a look. Here are two different parabolas. So this one right here will be an example of when a is greater than 0. So if our coefficient is positive, then we're going to have it opening up, like this first one here. This, right there, that is our axis of symmetry. You might also see me abbreviate it as AOS. Okay, you can do the same. Notice that the axis of symmetry goes through the bottom of the parabola at the vertex. So this bottom right here is the vertex. But because a is greater than 0 and our parabola opens up, this parabola is a minimum. So really make sure you understand the difference between the minimum and the maximum. The second parabola over here is when a is less than 0. Okay, so now we have a negative coefficient with the squared term. We still have our axis of symmetry, or our AOS. Our vertex now is on the top. The axis of symmetry still goes right down the vertex. So here's our vertex here, but this time, because our parabola is facing downwards, our vertex is a maximum. Okay? So these are the kind of things that I'm going to be looking for on your graphs of parabola. You don't just want to do the graph. We're also going to be labeling and showing that we identify with certain parts of the graph. All right, let's take a look at our steps. So the first step is what we worked on yesterday. That's calculating the vertex and the y-intercept. That's the first thing you want to do. The second thing you want to do is plot the vertex and y-intercept. Okay. The next thing is to draw a vertical line at the axis of symmetry. Remember, the axis of symmetry is a vertical line going through the x-coordinate of the vertex. So that'll make more sense here in a second, but don't forget to draw that. The reason why we draw that is we can actually take our y-intercept and reflect it across the axis of symmetry. Because the axis of symmetry means it's symmetrical, it means it's going to be the same on both sides. So we know we can reflect that point across that axis of symmetry. Once you have 3 points and one of them is the vertex, you have a parabola. So you can go ahead and connect your points. The last thing you want to do is just make a note. Is that graph a minimum or a maximum? All right, let's try graphing some of these. Let's start with this one over here, which is number 1 on your paper. So first thing we want to do is calculate our axis of symmetry and our x-coordinate. So that's where we're going to use x equals opposite of b over 2a. So now what we're going to do is keep filling that out. Opposite of b is negative 6 over 2a is negative 1. So we get 6 over negative 2. Sorry, negative 6 over negative 2. Then we get that x is equal to a positive 3. So I'm going to start putting my vertex up here. I know my vertex is at 3 for x. Now I need to figure out where it is for y. Well, I know y is equal to this equation up here. So what I'm going to do is wherever I see an x, plug in that 3. So I get opposite of 3 squared plus 6 times 3 plus 4. So now I'm going to go through and simplify that out. Well, here's that case where we're taking a number, squaring it, then making it negative. 3 squared is 9, and it's negative, so we do minus 9. 6 times 3 is 18. Then we're adding 4. So what do we have? Well, we have negative 9 plus 18 gives us a positive 9 plus 4, and that's equal to 11. So my vertex is at 311. So on your page, on your homework, you're not going quite up to 11. So this is one of those cases where we have to change the scale. Let's change the scale of our y. We're going to let our y's go up by 2's. My x's I'm still going to have go up by 1's. So I'm going to go 1, 2, 3 here. Then I'm going to go up 2, 4, 6, 8, 10. So then 11 is going to be halfway between there. Okay, so there's my vertex. Now I know that my y-intercept is my c term. So my y-intercept is at 4. Remember, our y's are going up by 2, so we're going 2, 4. We're plotting that point. Now, down my axis of symmetry, I have a vertical line. Okay, so now I want to figure out, I want to make a nice parabola for myself. So I have my axis of symmetry and I have my y-intercept. Well, now I want to reflect it over this axis of symmetry. Some of you can just see very quickly how to reflect it. If you can't, here's what you do. Take your y-intercept, then you're going to count, and you're going to go over 1, 2, 3. Well, I went over 3. That means on the other side, I also have to go over 3 to get to the same spot. On the other side, 1, 2, 3. Okay? So now that I have 3 points, I can graph my parabola. Make it nice and round. And you want to have a rounded top on that parabola. So if you accidentally made it pointy, go ahead and erase it and make it nice and round. So that right there is your parabola for that quadratic. You graphed it. You're done. Let's take a look at number 2. So for number 2, first thing we want to do is calculate our axis of symmetry. So we're going to use that x equals opposite of b over 2a. Then our opposite of b is negative 2 over 2 times our a, which is 1. So then we get negative 2 over positive 2. So x is equal to negative 1. Okay. Then what we're going to do next is we are going to plug that back in with our y to figure out what we get. So you get negative 1 squared plus 2 times negative 1 plus 8. So wherever I saw an x, I plugged negative 1 back in. We know negative 1 is the x coordinate of my vertex. Now I'm looking for the y. Negative 1 squared is 1. 2 times negative 1 is negative 2. And then we're adding 8. Well, 1 plus 8 is 9. And we're going to subtract 2 is 7. So we're graphing it at 7. I don't know why, it just flipped back to this page, but lucky you, you get to see the steps again. All right, so here's our vertex. Now we're going to graph it. Now your guys' might only go up till 7, so maybe you need to go by 2's again. So let's do that just in case. For our y-intercept, we're going to go up by 2's. For x, we're just going to go to negative 1 here, then we're going to go up by 2's. 2, 4, 6, 8. So 7 is halfway in between. Then our y-intercept is at 8, so that goes here. So there is our axis of symmetry going down the middle. So from 8, I'm going over 1 to get to the axis of symmetry, which means I need to go over 1 on the other side. Once I have 3 points, I can graph that parabola. So that right there is your answer. The one thing I forgot to do in the last one was to label my vertex. So think about that. Is that a maximum or a minimum? Look back at number 1. Was that a maximum or a minimum? Think, is the vertex the top or the bottom? Well, on this one, the vertex is the bottom, which means that this is the minimum of the parabola. And this is going to be really important, really important when we start looking into graphing quadratics and applying them, because we're going to use it for maximizing revenue, minimizing cost, those kind of things. It's going to be important that you can identify the maximum and the minimum. Let's take a look at number 3. So for number 3, I'm going to go through the work of getting it set up, and then I want you to graph it. Okay, so we're going to start by doing our axis of symmetry. So we're going to use opposite of b over 2a. So opposite of b would be a positive 2 over 2 times a, which is 1. So then we get 2 over 2. So we get that b is equal to 1. Or sorry, we get x is equal to 1. So we know our coordinate for our x and our vertex is 1. Next thing we want to do is plug that back in so that we can get y. So y is equal to 1 squared minus 2 times 1 minus x. Or sorry, minus 8. Wherever I see an x, I'm plugging in a 1 instead. So we get y is equal to 1 squared, which is just 1, minus 2 times 1, which is 2, minus 8. 2 minus 8 is minus 10. 1 minus 10 is negative 9. So my vertex is at 1, negative 9. So let's go ahead and plot the vertex together. Let's let our x's go by 1s and our y's go by 2. So we're going to go 2, 4, 6, 8, 10. So halfway between 10. We want to go negative though. So we're going to go down from 1, 2, 4, 6, 8, 10. So halfway is our negative 9. My y-intercept is at negative 8. So that's here. So here is my axis of symmetry going down that vertex. I want you guys to reflect that and then draw in the parabola. Then, I want you to pause the video and try number 4 on your own. Keep in mind that you might not have to change the scale on this one. It might work out really nicely for you. Okay, so go ahead, calculate your axis of symmetry and your x-coordinate, then get your y-coordinate, plot the y-intercept and the vertex, and then reflect it. Let's take a look at number 5. So for number 5, what you're going to do is you're still going to calculate the axis of symmetry. So I get x is equal to opposite of b over 2a. The opposite of b, well, there is no b. There's actually no c either. Okay, so the opposite of b is just going to be 0 because there is no b term. And a is 2. So I get 0 over 4. Well, 0 divided by anything is just 0. So my x-coordinate is going to be 0. I plug that back in to get y, and I get 0. So then my vertex is actually at the origin, which tells me that my axis of symmetry is the y-axis. Well, here's the problem. We've been using the y-axis to reflect our point. Well, we've been using the y-intercept to reflect it over the axis of symmetry. We can't do this time because our y-intercept is on the y-axis. So what I'm going to do is I'm just going to pick a point. I'm going to pick x is equal to 1. And I'm going to plug that in. Y is equal to 2 times 1 squared. I just picked a point. And I said x is equal to 1. Okay, let me solve that out. So I get 2 times 1, which is equal to 2. So when x is equal to 1, y is equal to 2. I just picked a point. I usually pick the next one over. So then I know that the point 1, 2 is also on this graph. So 1, 2. Well, now I can take this point, and this one I can reflect over the axis of symmetry. So I go over 1, which means I need to go over 1 on the other side. And then I can safely draw that parabola. Okay? I want you guys to do the same thing for the last one. So go ahead and pause it. What's going to happen is your axis of symmetry is going to be on the y-axis, which means you're going to have to pick a point. I suggest 1. Plug 1 in, see what you get for y, and that will lead you to your parabola. Make sure you take the quiz once you're done.